Okay, on to the second page here. I wrote a bit because in filming it the first time I got interrupted, and it's also fairly long and kind of a pain, so I apologize in advance because I wouldn't give you a problem like this on the test. But since you've got this and you're stuck with it, we're just going to make the best of it. You multiply 7x times x minus 3 in parentheses. You distribute that in, and you'll get 7x squared minus 21x. We distribute in the negative 2 here, and we'll get negative 2x, and then negative and a negative gives you plus 42. So double check to make sure you're okay there. When you gather up like terms, shove them all over, set it equal to 0, you should end up with this quadratic with 7x squared minus 24x minus 55. Now, it would be wonderful to pop 7 and negative 24 and negative 55 into quad form on your calculator, but you've been asked to use it, use the quadratic formula a long way. And if you do kind of grind it out, you will see that you get 24 squared, which is 576, and then minus 4 times 7 times negative 55 gives you a plus 1540. You wind up with 2,116, which is exactly 46 squared. So when you take the square root of it, you get 46. That means 24 plus 46 over 14 is one solution, and 24 minus 46 over 14 is your other solution. When you do that, 24 plus 46 is 70. 70 over 14 is exactly 5. 24 minus 46 is negative 22 over 14 is negative 11/7. So there are your two solutions for that problem. All right. Then when it comes to simplifying these imaginaries, you get 5i times 2i gives you 10i squared. Well, I squared is negative 1. So that's just negative 10. Well, negative 10 times a negative 3i is positive 30i. Okay? You can also just multiply all the numbers together and then deal with all the i's being multiplied together. I to the third is a negative I, and negative I times negative 30 also gives you the positive 30i. Here we're foiling. These are two complex numbers, they're called. And you FOIL them out, you multiply the number part, you get 4. You do the rainbow part for the i's, and negative 2i plus positive 12i gives you a positive 10i. And then you get the i's multiplying, and you get negative 6i squared. Well, I squared is negative 1, so negative 6 becomes positive 6. 6 plus 4 is 10, and the final answer is 10 plus 10i. So check that out. This is just a plus. So we're adding two complex numbers. We add like terms. 4 plus 2 are the number parts. That's 6. Negative 2 plus a negative 5 is a negative 7 for the I part, so negative 7i. Here, I to the 79th, use those tricks we learned in class. You take out batches of 4 i's. They're all equal to 1. If you do that mathematically, it's dividing 79 by 4 and looking only at the remainder, which is 3. I to the third is I squared times I. I squared is negative 1. Negative 1 times I is just negative I. So that's it for the non-calculator part. Going on to the calculator part, we've got 3 consecutive odd integers. Odd integers go like 3, 5, 7, and when they're consecutive, that means they're in order. If you'll notice, you can choose x to represent the first one, or you could choose any of these, but the easiest is the first one. The next odd number would be x plus 2, and the next odd number would be x plus 4. That's kind of the breakthrough trick you need to understand, that in math we'll represent what we don't know with a letter, and then we try to build on that letter based on the rules of what we're doing. In this case, they're consecutive odd integers. If they're just consecutive integers, it'd be x plus 1 and x plus 2. But because they have to stay odd, we have to add 2 and then add 4. The product of the first and the third, well, there's the first one, there's the third one. When we multiply those, that's 35 more than 10 times the second. So if we take 35 away, that's going to be equal to 10 times the second number. Okay? When we do this, you'll get a quadratic. You'll get x squared plus 4x minus 35 equals 10x plus 20. And alright, that's annoying. I got a pencil that works. Here we go. X squared plus 4x minus 35 equals 10x plus 20. Again, gather up your like terms. I've got x squared over here in positive, so I'm going to keep that there. There are no other x squared terms, but when I take away 10x from both sides, I get minus 6x. When I take away 20 from both sides, I get minus 55, and that's equal to 0. Well, hopefully that's factorable. I'm going to see if I can get it to work just quickly like this. You could put it in quad form on your calculator too. But the only way to make 55, I'm guessing, is 5 and 11. And it does have a difference of 6. So that's minus and plus. So that factors easily. This is the solution that's positive. That equals 0 when x is equal to 11. So that would mean that consecutive are 13 and 15 for my odd numbers. Of course, if I'd wanted to, I could say negative 5 and negative 3 and negative 1. But on the test, maybe I'll say consecutive positive odd integers. And that's the solution. Alright, the next one, solve the following. Write any solution to 3 decimal places. For about the 5 billionth time, we shove it all over equal to 0. It becomes 5.173x squared. When I combine the x terms, I get plus 4.319x, and then minus 8.309 equals 0. So then I can go to my quad form program, and there it is. Hit enter, enter A. So 5.173. B is 4.319. And C is negative, don't forget the negative sign, 8.309. Hit enter. And according to this calculator program, my solutions are x equals, and I'm going to round to 3 decimal places, 0.917 when I round that, and x equals negative 1.752. Okay, so those are those solutions. Finally, number 12 says solve the following system by graphing. Sketch the graphs and label the points of intersection. Well, I've typed those in already into the calculator, and there's the graph in the Zoom 6, the standard window. Looks like I want to see the upper area. There's nothing interesting happening down here, so if I go to the window, I'm going to keep my x's, but I'm going to make my minimum y, well, maybe I'll make it negative 1 so I can see the axis a little bit, negative 2, but I'm going to go up to 20 for the vertical, and then I'm going to look at the graph. Oh, I can just see the top of that, and here's the other one, goes down. So I'm going to sketch this something like this, and again you can adjust the scale to suit, and then it looks like it hits pretty close to the top, comes down, there's the vertex down there, goes up like that. So that's about as ugly a graph as I'll see on a test, but that's good enough to convey the fact that you've typed it in carefully. We just want to find that point of intersection and that point of intersection right there. To do that, I do second trace button to go to calculate. I press number 5 for intersect, and then I can just do enter, 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 and see which 0 it gives me. It's giving me this 0 down here, and that's at x is 1.519, and the y is 4.096. 4.096. I want to find this one over here now. I'm actually going to change my window just to see a little bit above that because it's annoying. I'll go up to a maximum of 25, and my scale I'll maybe make every 2. There, that is. Now I can see it clearly. So I'm going to do the same thing. I'm going to do second trace to get to calculate. I'm going to choose number 5 again, but now this time I'm going to be careful to steer my cursor closer to the intersection I'm looking for, and I just do enter, 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 and it will give me that one up there. And now that is given to me as negative 2.853, and the y is 20.126. 20.126. Alright? So there's the first, there's the second. Solve the above using algebra. The way we do this is we're going to set these equal to each other. So I'll write 2x squared minus x plus 1 equals negative x squared minus 5x plus 14. And for the 1,000,000,002nd time, I'm going to move everything over so it's 3x squared. Then I add 5x to both sides, plus 4x then, because I'm adding x squared to get those to cancel. I should show my work. And then I'm adding 5x, and then I'm subtracting 14. So that's minus 13 equals 0. So now this I would put into the quadratic formula, and I would have minus 4 plus or minus the square root of 16, that's b squared, minus 4 times 3 times minus 13, all over 2a, which would be 6. And so I would get a final, well, I'm getting there. Here's where I can use my calculator. 4 times 3 is 12. That's negative 12 times a negative 13. 121, that's 33. So that would be negative 4 plus or minus the square root of 16 plus 133. 149 all over 6. Okay, so that's fine. You could take and cancel a 2, but you'd have to take out something here to cancel as well, so I'm just going to leave it like that. Those are the two values for x that are going to work. It says find one solution, so you can pick either one of these solutions and sub it in. That would then mean that you're going to take and sub in and find y equals 2 times, and that's negative 4 plus radical 149 over 6 squared minus 4 plus square root of 149 over 6, and then plus 1. Now, on the actual test, those will work out more nicely, and you won't have these horrific things to actually work out. This is the important part for the practice test. If you were able to get to that, that's good. If you were to graph these and get the solution there, that's excellent. That's all you need to know. Thanks.